Hey, so this is Eric over at TechnoRV. Super excited today to learn about a product that we've just launched on TechnoRV.com. It's called SoftStart RV, and it's got all to do with your air conditioner units. And one of the things that we do to make sure that we're getting great quality products is we like to vet these through industry experts. And so one of the people that I talk to quite frequently about things regarding electricity, technology, is Mike Sokol. I consider him an industry expert. I've learned a lot from him. You've probably heard of him from his Facebook group. He does a lot of articles. And so bringing Mike Sokol in here, how you doing, sir?
Very, very good. Thank you so much for having me, and welcome everyone.
Yeah, absolutely. So listen, we just took on a product, as you know, called SoftStart RV. And as I was going through this process, I had called you and asked you all these sorts of questions. So if it's okay with you, I'd kind of like to rewind the clock and sort of ask you all these questions again so that the audience can hear the answers. Does that sound good?
Go for it.
All right. So regarding air conditioners, I've heard a lot of talk about something called inrush or starting current as it relates to the air conditioner unit. And I'm just going to leave it at that and let you talk about that for a little bit.
Okay, so this is one of these things I've been doing, installing industrial electric motors and troubleshooting them for 50 years. And this is the thing that you see when an air conditioner starts up, or even your vacuum cleaner, or almost anything. You'll see like your lights dim in your house for a second or so. And this is what we call this inrush current. It's basically the extra current that motor needs to get the compressor started and up to speed. And even though I had read about this in textbooks for years and years and years, I had to do a little studying on this, and I found that things did not seem to have all of the proper information that I wanted to learn about this. So I went and built my own gadget to go test this. I built something called Hurdle.
Okay.
And you can kind of see that's for high rate data logger. And you can see on the screen here, this is a gadget that I cobbled together out of my parts and my background. It's basically like a high-speed digital storage oscilloscope, but I can record at 192,000 bits per second, and I can record for hours and hours if I want, and then I can put it into a nice graph that everybody could see.
And
so
Mike, I'm not surprised that you came up with something like this, by the way. This is great.
It is so much fun because basically this uses a lot of audio gears. Many people know I'm a pro audio engineer. And so if you look here, you can see my little cursor on the top. This is the inrush current that you get. Now, these little wiggly lines, that's actually the 60 hertz cycle. You've heard about 60 cycle AC, 60 hertz AC?
Yes.
That's what we're seeing. I'm basically measuring the hum of this system. And so this red bar up here is showing us how much current. So you can see in the beginning here, you got like 4 amperes or so and the fan motor's running. And then what happens is when that compressor kicks in, when it's calling to make it colder, it jumps up. In this case, it's jumping up to about 52 amperes or so. And it does it for a very, very short period of time, about 1/6 of a second. And then it goes back down, it rebounds around. You know, the people tell me that that's likely bubbles collapsing within the Freon stream, which I think is really cool. And it goes back down to the normal running current that we get on. This is a Dometic 15,000 BTU air conditioner. Pretty typical, you know, just a regular rooftop air conditioner.
Sure.
So this inrush many times is 3 to 4 times the normal running current. And where you get into trouble with that kind of thing is the fact that, well, generators don't like inrush current a whole lot. You can get away with it on your home. You can get away with it if you're plugged into a pedestal that's fully powered. But you may not get away with it if you're in any kind of limited power situations.
Yeah. So let me ask you a question about the hertz. I've been, as you know, I full-time RV, and I do keep a close eye on the power consumption, all these sorts of things. I've never once seen my hertz fluctuate from 60. In these situations where you have this spike, is that affected at all, or is that a non-issue?
No. Okay. So 60 hertz is basically the entire United States electrical grid, except for Texas, I think, because they're on their own little, they do their own little thing. They run exactly 60 hertz. This is all crystal controlled. Every generator in the United States is running exactly in synchronization. There is no way that you as an individual can draw that down and change that frequency. But you can't, let's say you had a big generator, like a great big dynamo generator, we do for rock concerts. When they kick drum would go, we could actually watch the hertz dip because the engine would go, that kind of a thing. You'll never see it change. However, if you had this hooked to a dynamo style generator, like a Cummins Onan generator in your RV, you could see that thing deviate 59 hertz, 61 hertz. Most gear doesn't really care about that unless, as you know, I'm a musician, unless you're playing a Hammond B3 and then it goes out of tune.
Right.
We don't like that a lot. But vast majority of time, one plus or minus 1 hertz, never. That's really basically cycles per second. So right around B flat.
Well, I don't believe you ever play out of tune, Mike. So, unacceptable, right?
That's not acceptable. Not acceptable at all.
So, this Inrush, if I saw your graph there, it seems like in the example that you gave right there, it seems like there was this Inrush of about 52, 53 amps. Is that common across most AC units that you might find on an RV, or is it a little bit higher, a little bit lower?
It could be a little bit higher. I was on a fairly long line that had a little bit of droop to it when it calls up. And I did that on purpose to kind of simulate what you would have at a campground. If I was on very close to the power supply coming in, the service panel, it might be 60 or 70 amperes peak.
Got it. Okay. Wow.
Just depends because it's dragging down a little bit. I'm going to do some more experiments with that in my lab. But this is fairly common, this 50-ish kind of amperes of current. It happens in the blink of an eye, but it's enough to make lights dim.
Yeah, so, I'm in a 50 amp RV. I've got 3 AC units, and then we do also have a smaller 30 amp RV that's got 1 AC unit in it. But I've certainly had moments where I've been on a 30 amp pedestal in my 50 amp RV and needed to be mindful of that I could only run 1 AC unit, and I presume that it's this Inrush that is keeping me from running 2 AC units. Would that be a fair statement?
It is, and remember, and a lot of people don't understand the difference between a 50 amp service and a 30 amp service is a lot more than you think.
Yeah.
A 50 amp service is actually 100 amperes of current at 120 volts. So now you're going from 100 amperes, which you can do pretty much whatever you want, down to 30 amperes, which now you have to do what we call manual load shedding. That is, you got to be careful. It's most of the time you get into trouble attempting to run 2 air conditioners on a 30 amp feed from a campground.
Yes, absolutely. So I want to bring in the idea of the SoftStart system, and I've got one here just so that people can kind of see what it looks like. They're not very big. But the SoftStart is a device that will sort of level out, minimize that inrush. Can you talk about that and maybe give us some details on what exactly is going on that's making that happen within this device?
Yeah, it's kind of neat because this is what I built my hurdle device for, because what was happening, the best meters that I had would actually sample this 5 times a second. This whole event takes place in under, a tenth of a second.
Okay.
So what I did was, you can see the top half up here of this graph is with the stock, what we call the starting capacitor.
Yep.
And then the bottom half of it is exactly the same unit 10 minutes later after I swapped in a SoftStart RV. And so what's happening is, instead of this big smack, like dropping the clutch on a car and squealing the tires, This is kind of like a hydrostatic transmission. That baby goes whomp, and you can see on my graph that it's building this up. So it takes twice as long to start it. Now, when I say twice as long, it takes 1/3 of a second rather than 1/6 of a second.
Yeah,
but
sure.
It does reduce the peak. So in my case, what I measured, you can see over here, I'm starting with 4 amperes of the normal fan running. And then what it does is I limit this to less than half. So it's about 24 amps peak current. Then it bops back down to the normal 13 amperes. So a SoftStart RV unit does not decrease your normal running amperage. What it does is it cuts the peak current in half, this inrush current in half, which is what allows you, and usually it's that inrush current which trips circuit breakers or makes generators behave badly.
Got it. So if we can reduce that inrush, like you're showing here,
yes.
What are some things that an RVer may be able to do that they otherwise wouldn't be able to do without the SoftStart device?
Well, what I've been doing is experimenting. You can actually run a 15,000 BTU air conditioner. I'm running it off a little Honda EU 2200 generator. So basically a little 2,000 watt class generator can in fact run it. Now, it doesn't run a lot of other stuff at the same time, but it actually works really beautifully. It starts at every single time. Whereas if I don't have it, I may only be able to start it successfully 30% of the time. And the other 2/3 of the time, it trips the generator off. So that's what allows me to start that up quite easily because of that.
So if I've got a 30 amp RV with one AC unit, I would be able to run my AC unit off a 2,000 watt generator?
Yes. The other thing that this does, and I think this is really, really important, if you're in any kind of a situation where you've had, a hurricane, tornado, power outage, and let's say you're out mooch docking. And this is a new term I just heard. Mooch docking just means you go hang out in your brother-in-law's or friend's house and you just plug into like a 15 or 20 amp outlet on the side of the house.
We're going to get you all up to date on all the RV terms, Mike.
Who knew? So let me just kick back to my face shot. So this allows you to actually go plug into a regular conventional 15 or 20 amp outlet on the side of the house and be able to run your air conditioner.
That's great.
Which I think if you're a first responder, I had dozens and dozens of emails saying my wife, we've got our camper in the backyard. We just want to plug it into a wall outlet. She doesn't want to come in because she's helping in a COVID ward. Or I've got first responders that are down right now down in Lake Charles, trying to put the electrical grid back together after the hurricane damage here a couple of weeks ago.
Yes.
And they're saying we have limited power. What can you do? And I said, you need SoftStart RV because again, that helps reduce all of those that stress on the system.
Yes. Well, you know what? We talk to RVers all over the country, and everybody has got unique situations. But I'm not surprised that almost everybody at some point or another when they're RVing is going to run into a situation like this where that spike in that AC unit is going to cause a problem. I've got a friend of mine, and I wanted to run this by you. He's got a big fifth wheel. It's a 50 amp. It's 3 AC units. I don't know the rating on the AC units. He's got a generator, and I don't know the size of his generator. But what he says is he cannot run all 3 units on the generator unless he stagger starts them.
Right.
And then even then, it's sort of a hit and miss. So would that help him?
It absolutely will. And now remember, you will need a SoftStart RV for each rooftop air conditioner. So if you've got 3 of them, 2 of them, you need that many of these SoftStart units to do that. Okay. But if it'll run them all normally, you've got to stagger them. The fact that it will reduce that starting current to less than half of what it would normally mean would in fact help with all of that sort of thing. Okay. And the other thing that's crazy with this, and I finally got this Dometic air conditioner off of my bench and stuck it outside and ran cabling out and everything. You can't hear it when the compressor starts up with this. It's like goes whoosh. Instead of normally you have a bang and you can actually hear it shudder and bang. It doesn't shudder and bang with this unit, which means you can sleep through it. Which who knew? Who knew?
So some other positive side effects I was going to ask about that. That's interesting because I hear that sometimes too. With that, again, it's like sort of hitting a brick wall. You just hear it starting up. Is there any? I don't know if I'm pushing my luck on the side benefits of this, but would I be using less electricity? Would it be noticeable, or is that pushing it too much here with this?
Well, so let's go back. Now, I am going to avoid the calculus here because that's actually what it would take to show this.
But you could do it though, right, Mike?
Well, my kids are better at calculus than I am. I haven't done it since college. I haven't really needed to do it. But if you look at over here, you can see we have a large amount of current, high amount of current for a shorter amount of time. And with the SoftStart, you have a lower amount of current for a long time.
Yes,
if we were to look at the areas, and it's like square inches or whatever, under these two things, here versus here, they're going to be very, very similar.
Yes.
And so that does not really reduce the amount of wattage or power that you need because it is actually doing half as much current for twice as long.
Yes.
That's the easiest way to think about that stuff. So if I wanted to, and I don't want to, I could apply the calculus. We could show that, but just trust me. It doesn't really help anything except it just assists the generators or any limited power situation. Be it mooch docking or a pair of air conditioners on a 30 amp. It just assists it in getting the thing started without less of a grunt.
That makes sense. So I did a install of the SoftStart unit here on my 30 amp RV, and I intend to put 2 of these on my 50 amp RV. And so, in fact, I'll probably put it on all 3 of them just so I don't have to pick and choose which ones I use on a hot day. So the installation I found to be very easy after I sort of studied the instructions. There was a video that SoftStart provides, and I just kept in my mind that, look, it's 5 wires. How hard can this be, right? Do you have any suggestions or any feedback on your installation that you might have for somebody that's planning on doing the install themselves?
Well, a couple things to do is you guys all have a high resolution camera on your phones. I cannot tell you the number of people that have disconnected stuff and then they call me up and say, how does it hook back up? And I'm going, how the heck am I supposed to know? So you take pictures of this. You document your pictures, right? The other thing that I did, and let me see if I've got this. Yeah, I do. I use Waygo lever connectors for this. This Waygo stuff is terrific.
Okay, yep.
And basically, this guy, you just pop this little lever loose, and then you slide the wires directly inside, and then just snap it back down. And these are rated for all kinds. I mean, this is so far superior to regular twist nuts. And now, I've had people say, well, these things will pop loose. Well, if you feel silly about that, put a wrap of tape around the darn thing. But this allows you to take it in and out. This is how I've been able to successfully install and deinstall my SoftStart unit half a dozen times as I'm doing my experiments. So this stuff is so much better. I actually have an article about which we can send you a link. I call it Let Go My Waygo. Actually, I think it's pronounced Wago. But I'm sorry, I've changed the pronunciation of these guys to fit my cutesy little article. So these Wago connectors, these lever action guys are great for that. The other thing I will tell you, and a lot of people don't understand this, when you're up on a rooftop of an RV that might be 10, 11, 12 feet tall, it's dangerous if you fall. So you have to take all your safety precautions about, ladders and safety and good shoes. I teach a lot of safety things, and I got to tell you, most electricians who die while working on roofs don't die from electric shock, they die because they fall off the roof or they fall off the ladder.
Sure.
So you still have to have good safety precautions, and you want to make sure that you are disconnected from all power. Make sure your inverter is off, your generator's off, you're unplugged for everything. I hate to sound like I'm paranoid, but I'm paranoid working around live electricity, so make sure all of that stuff is down.
Yeah, I remember it's a OSHA standard called lockout tagout, and it's the idea that you would take the your plug and actually lock it out to make sure that nobody else could plug it back in if somebody was working on a piece of equipment. So for RVers, a lot of times they can just completely roll up their units back into their RV. I would suggest not just leaving it on the ground right next to the pedestal where somebody could come by and plug it in.
We call it Lotto. In fact, I'm getting ready to do an SOP, a standard operating procedure for campgrounds about this for technicians and maintenance guys working on things. So lockout, tag out, at the very least, I wrap a piece of tape around things and just put, do not use. In the industrial world, we actually have a hasp that goes on there, and we have a key. We have actually a little lock that goes on it, and the lock has my name on it, and I've got my key. I'm the only guy with that key. To that lock. Sense. And then, we might have 4 or 5 electricians working on things. We all put our locks on this thing.
Yes.
And until everybody, and when everybody comes off of this thing, all the locks are removed. But it is a serious fine, an OSHA fine, and you would be fired if you went ahead and say, I'm just disconnected, I'm cutting his lock off. If his lock is on there, he's out there in the field someplace. You go find him and you drag him back there. And maybe he's hurt. Maybe there's a problem. And a lot of people don't understand that. But you're right. You do not want to just leave this thing plugged in and turn off the breaker in the pedestal because some good Samaritan's going to come by and say, oh, his air conditioner's not running. Let me turn the power on for him.
Poor guy, let me help him out, right?
Let me help him out. People generally don't do these things out of any kind of vindictiveness. They just do it because they don't understand.
Yes.
Like I said, I'm paranoid. I've been doing this very seriously for 50 years and casually for 60 some years. So be careful.
Yeah. So I've got one more question. I've heard this idea of I believe they call them hard start capacitors. So your AC unit has a capacitor, but it's my understanding this is some kind of stored energy type capacitor that can help a unit in certain times. How is that different or applied to AC unit versus the SoftStart?
Oh, this is a great question. And I was confused about this a year or two ago too, because I had all kinds of people ask me tons of questions. Hard start, soft start, what does all of this kind of stuff mean? Now, I don't have a graph up here of the exact thing, but I'll show you what it does. And in fact, I applied Hurdle, my high rate data logger, to it. Okay. And what I found was a hard start capacitor does the whole 52 amps, and it does it for twice as long.
Oh, okay.
So you can imagine it's not a storage thing. That capacitor does not store electricity. It's strictly about phase shift to get the magnetic flux spinning in the right direction. That's all it is. So it's not a storage thing at all.
Okay.
So what it does is it does that 52 amp peak, but then it lasts for over a second in length that it's holding it. So they really were used on old aging air conditioners that were having trouble starting. And what it does is it kind of gives it a bigger kick in the butt.
Right.
Try to make it go. Now, I've not done a bunch of extensive testing yet, but from everything that I've seen on that, everything I've seen says that it would make it even harder to start that air conditioner if you were in a limited power situation, like an inverter generator. So more experiments to do. Supco, though, is a manufacturer of that, has sent me a whole box full of them. So I have every one that they've made, I think. So, and they said, test it and tell us what's going on. But we feel in many cases it helps. And in some cases it may help, but I don't think it's going to help you on a Honda 2000 generator. No. That's just my how I'm seeing how all of this operates, unless I'm doing something really, really wrong and looking at it incorrectly. But I'm pretty sure I understand what it's doing, I think. I think.
Yes.
But time will tell. As you guys know, I'm retired from my live gigs of climbing around and doing big rock concerts and everything. And I can't really travel around the country, do a lot of seminars, so I'm stuck in my laboratory. And it is turning into a real lab. And so I can now answer these questions and do videos about them. So this is what I'm wanting to do. These are my upcoming projects. It'll be a lot of fun.
Well, Mike, I want to come visit your laboratory someday. I always love talking to you, and I always learn something when I talk to you. And just so that folks know that are listening, I do, as it relates to electricity and technology, I do rely on Mike on a lot of things as it relates to the internal workings of things to make sure that I am presenting the right information to our audience. And so I appreciate your time and your help. I'll give you last word, Mike, if you want to say one more thing about SoftStart or anything else.
Well, if you want, I have a little 3-minute video here that I could run that actually shows us how it works in real time.
Yeah, let's do that.
Would you like to see that?
Sure.
We pop on over there and you can kind of see this, and then we'll be done.
All right.
Let me make sure that I'm sharing. Hang on one second. Let me make sure I'm sharing this with the sound. Because that's always embarrassing. Share with sound. There we go. And this is stuff that I did in my own lab, so it didn't come from some, manufacturer's thing.
Okay.
This is a video showing the peak currents comparing a stock capacitor in a Dometic Penguin 2 air conditioner with the SoftStart RV modification. The left graph shows you the peak current from the stock capacitor. The right graph meter is going to show us the peak current after the SoftStart RV modification. Let's take a quick look. A little too fast to see, isn't it? Okay, so the left meter is going to show us the 52 amp peak current that we get with the stock capacitor. We can see that's in red. The right graph is going to show us the 24 peak from SoftStart RV. And that's the graph in yellow. Now it's a little hard to see, so I'm going to slow that down a bit. Here's our fan running. Right here is going to be our peak. You can see it's going to redline the meter for a stock capacitor. Comes back down to around 14 amperes or so, which is what normally you have with a regular air conditioner running. That's all good. But that 52 amp peak is what causes a lot of air conditioners to trip, generators and receptacles that may have limited amounts of power. Let's go look at the SoftStart RV side of it. You can see, again, it's going pretty fast. Let's do it, slow it down. Here we're at the 4 amp fan draw. It's going to take a lot longer to build up, and it's only going to build up to 24 amps peak, comes back down to around the same 14 amps or so of running. So the difference between the two technologies is you have a very short peak current of 52 amps with stock capacitors, and you have a much longer drawn out time with a lower amperage for SoftStart RV. Now okay, so let's just head back out of there. But I think, this is the kind of stuff I enjoy doing because, again, I'm building all the gadgetry to do it. But this shows you the difference. So the next time if somebody asks you how one of these things works, you can say, well, does slower current, less current for a little bit longer time, it just makes everything just work much easier.
Well, it's one of the most well thought out demonstrations of something like this that I've ever seen. So I know people will be thankful that you've taken the time to put that together. Hey, Mike, where can people? You got a Facebook page that I love going to. Where's all that stuff at?
If you go to Facebook, the RV Electricity Group, all of my stuff is over there, and we have a very, very active group. I'm over 10,000 users now.
That's
10,000
awesome.
on a Facebook
Wow,
group, which
that's
is good.
incredible.
And we run it with an iron fist. I mean,
Yeah.
there's nobody yells at anybody. Nobody calls anybody names. They get one shot and they're gone.
Yes.
Also, all my videos are over on my YouTube channel, which is also aptly named RV Electricity. You can also find tons and tons of my articles over on rvtravel.com. And I do a regular column there every Saturday on my RV Electricity column. And I also do a thing on Mondays, which I call my jam session. Just Ask Mike.
Yeah.
Get it? Jam session.
Yeah.
Too cute, huh?
That's good.
And you can see a little bread with jam on it, strawberry jam. And I have hundreds and hundreds of articles. This is my 10th year of actually writing for the RV industry. And so I've got many, many hundreds of articles out there. You can find almost anything about generators, AC powers. Now I'm diving more into batteries and solar, hybrid inverters. Oh, I got lots to learn. I'm retired from my regular job, so now I'm getting in trouble, in my shop.
Well,
so all good.
Hey, I'm along for the ride. I got located you early on in my RVing tour with your book and read through that, and then soon after that, I guess we got introduced probably at the Hershey show, I guess, and so I've been along for the ride ever since, and I'm looking forward to seeing what all you have going on in the future. So I appreciate taking time, and hey, we should do this again.
Yeah, we will. This is all great. Thank you, everybody, for taking the time to watch us, and thank you, Eric, for inviting me along for the ride.
Yep. Thank you.